All right, so we're all seeing the AI revolution happen in real time, right? It's everywhere. But what you might not know is that behind all that incredible software, there's a really physical, really tangled problem, a massive roadblock. So today, we're going to dig into that hidden challenge and look at a pretty wild new solution that wants to, well, literally cut the cords on AI's future.
And that really brings us to the big question for today. With all these amazing leaps forward in AI, what is the one thing physically holding it back? What's the hidden brake on this whole explosion?
Yeah, and this slide just perfectly captures that disconnect. On one side, you've got the sleek, futuristic promise of AI, vast, interconnected intelligence, even out in space. And then you look at the other side. That's the reality, a chaotic, costly, absolute rat's nest of physical cables that's actually making it all happen. Okay, so to really get why those cables are such a huge deal, we first have to wrap our heads around the sheer scale of AI's growth. I mean, it is just mind-boggling. We're talking about an appetite for power and resources like we've never seen before. First step, just follow the money. We're talking over $1 trillion, with a T, expected to be pumped into data centers by 2030. It's a full-blown infrastructure arms race, and you guessed it, AI is the engine driving the whole thing. And it's not just about the cash, it's the incredible speed. The demand for AI compute is growing 4 to 5 times every single year. Think about that. It means the need for this power is doubling roughly every 6 months. The hardware can barely even keep up with that pace. And all that computing, well, it takes a truly staggering amount of energy. We're already at 945 terawatt hours, and that number is just climbing. To put that in perspective, that's about 3% of all the electricity on the planet. Or, enough to power the entire country of Japan. Wow. So, okay, we've got this absolutely insatiable demand for AI, and it is running smack into a surprisingly old-school problem. It's time to introduce the villain of our story, the humble, everyday cable. I mean, just look at this picture. This is not some old, forgotten server room from the 90s. No, this is the reality inside a modern, high-performance data rack today. It is a dense, tangled mess, and it creates a whole cascade of problems. Okay, let's really break down why this mess is so bad. First off, infrastructure. A full quarter, sometimes even 30% of a data center's build cost is just for the cabling. Then there's the long-term cost. When you factor in the fiber, the copper, the specialized labor to manage it all, it can jack up the total cost of ownership by up to 60%. And they break. Cable failures cause these major incidents. We're talking over $100,000 a pop, and they affect more than half of all data centers every single year. And finally, trying to scale or upgrade is a total nightmare. A simple change to one rack can take 8 to 12 hours. That's a whole workday where you're not deploying new services and you're not making money. So here's the bottom line. At the end of the day, these physical interconnects, these wires, have basically become a hidden tax on AI scalability. For every step forward we want to take, we're paying this tax in cost, in complexity, and in just plain fragility right at the heart of the whole system. All right, so that's the big, tangled problem. But what if? What if we could just get rid of that tax completely? Well, this is where the hero of our story comes in. It's a new idea called the wireless fabric. And this right here is what it looks like. Say goodbye to that tangled mess. This is a wireless network interface card, a WNIC for short. And it's as simple as it looks. It's a plug-and-play card that's designed to replace all of that copper and fiber by creating super fast wireless links between servers right there inside the rack. So the big idea here is creating something called a wireless fabric. The easiest way to think about it is like a private, super-powered 6G network, but instead of connecting our phones across the city, it's creating this incredibly fast, self-managing mesh right inside the data rack. It just completely replaces the physical wires that used to chain everything together. And you gotta appreciate the ambition here, because it is huge. The goal isn't just to tidy up a few data centers. No, it's to fundamentally change how data moves, period. We're talking about aiming for instant transmission, whether that's from one server to the next, or from here to Mars. Okay, so that's the grand vision. It's pretty cool, right? But how does it actually translate into a real-world advantage? Let's get into the nitty-gritty of how cutting the cord actually makes things faster, cheaper, and a whole lot better.
Well, it really just boils down to simplicity. See, in a traditional wired setup, for data to get from one server to another, it has to make a few hops. It goes from the server to a switch, and then from the switch to the other server. That's 3 steps. With a wireless link, it's a direct shot. One server to the other. Just one hop. And fewer steps means less delay. It actually cuts the latency, that lag time, by more than half.
And hey, the numbers really back this up. If you stack it up against even the best high-speed copper and fiber optics, this wireless solution delivers the absolute lowest latency. We're talking under a single microsecond. On top of that, it uses the least amount of power for each link. And of course, the flexibility, it's completely off the charts. I mean, there are no physical cables to mess with. So the tech is faster, it's more efficient. That's great. But what does this really mean in the real world? Well, this is where the story gets really interesting, because we're about to see the impact scale up from a single server rack all the way to the final frontier. Let's start with the bottom line, because that always matters. For every single server rack, going wireless can slash the total cost of ownership by an estimated 40%. 40%. For companies building these massive AI factories, a number like that isn't just good, it's a total game changer. And then when you scale that up across a whole data center campus, the savings just become staggering. Let's take a typical 5,000 rack facility. You're looking at saving over $17.5 million on the initial hardware costs. Then you save another $13 million or so in operating costs over 5 years. And maybe the biggest number of all, you save around $20 million just by avoiding that expensive downtime caused by cable failures. It adds up fast. So this is what you get at the end of the day. A data center that's not just cleaner and way more organized, but one that is fundamentally more agile. You get an infrastructure that can literally reconfigure itself on the fly to handle whatever job you throw at it, all without a single person ever having to crawl around and unplug a wire. But the vision here, it doesn't just stop at the ground. Think bigger. Think about putting data centers in orbit or building a base on the moon. You just can't run miles and miles of fragile fiber optic cables in a place with zero gravity and constant vibration. In those kinds of environments, a cable-free design isn't just a nice to have. It's not an optimization. It's pretty much the only way it's going to work.
And that really is the ultimate goal here. We're talking about building the backbone for a completely new era of computing, a backbone that connects everything from the massive AI clusters here on Earth to the autonomous systems we're going to send out to explore other worlds.
Which leaves us with one last, pretty fascinating question to think about. For the better part of a century, our entire digital world has been physically tied down by wires. So what new possibilities are we going to unlock? What incredible things are we going to build once we finally cut them?